My name is Barbara. I'm a senior architect in the mobile web team at the CBC.
And of course, I'm Blake Crosby. I am the team lead for the system administration, system in operations side at CBC.
All right. So today's workout. Who did go to the gym this morning?
Nice.
I did. Okay. If you haven't, that's fine. So we'll do a quick workout today. So that's good. But before we get started, we want to draw some attention where we're from. So we're from Canada. But who and what? Who is here from Canada? Yay.
Nice.
Wonderful. Great. All right. So Canada is famous for this guy. And also, of course, Celine, right? We all love Celine. But there's also the CBC, the Canadian Broadcasting Corporation, that is from Canada. So we're the nationally public radio and television broadcaster. We're kind of like the NPR, PBS, but not really, because we still need a commercial advertising to supplement our federal funding. We have large internal and external digital systems, so we have to work with a lot of data sources, data feeds that we're coming in, we're sending out, so there's a lot of interaction and a lot of stuff happening. We have 3 mobile websites. We have 11 iOS apps, 3 Androids, 5 BlackBerry, and 3 Windows apps. Our desktop sites get normally per day about 5 million page views, just to give you some numbers. Our mobile touch site gets about 500,000 page visits per day. And our news app has about 1 million page views per day. All right, and our mandate from 1998 says that our programming should be made available throughout Canada by the most appropriate and efficient means. And that, to us, definitely says we should focus on performance and really save where we can. And that brings me to the point why we're all here, performance. So why the need for speed? Why is it so important? Well, because people do not like to wait. They hate to wait. And it's as Steve even mentioned last night, it's the perception of speed. Something feels slow if you're not informed, if it's boring. And something feels faster if you're informed and you know the progress of what you're waiting for. So as Brad Frost quoted, ultimately, performance is about respect. What about mobile and performance? Mobile and performance, why is it so important? Why is it so crucial? Well, I'm sure most of you have seen this graph, and it kind of illustrates where we're going. We're going towards a browsing world where users will browse the internet more on their mobile device than on their desktop device, and we're probably hitting that target by this year or next year, based on those reports. Also, performance, what's important on mobile when it comes to performance? Well, we have a battery-driven device, and there was a really good paper that was published. I think that the person who wrote the paper was also here last year. It was called "Who Killed My Battery?" So I highly recommend reading that paper, because it outlines that JavaScript and images are the big culprits in terms of draining a battery. We also have a small CPU and GPU on our device. There's always network connectivity issues or constraints that we have, and latency. We never know where the user is. And the last thing, I think, which is also very important, is the data usage. Especially in Canada, it's still very important to have data plans, and you don't want to make the user pay for your bad performance. So it's up to you to change that. So you're dealing with impatient users, and that report from Gomez says that 74% of mobile users expect the page to load in 5 seconds or less. All right, so, and again, quoting Steve, Steve wrote a really great article describing how to create a performance culture. And one of the things he said at the beginning, he said, you should start with metrics. And I took that serious, and I said, let's really do this. Let's get started with that. So the first thing is, what do you want to measure? Where do you want to start? So I looked at a CBC page. A CBC page is there to tell you a story. So you have a header and a footer, and then you have the story that you want to tell. So it could be text, could be a video, could be an image, could be audio. And then on the other hand, we have those things called the third-party scripts, right? So we have to include tracking, we need to include ads, and a bunch of other things that keep our research team happy and busy. So let's do a quick assessment first of the desktop and the mobile site. So this is a typical CBC story. It's a hockey story, loaded on an iPhone. So that's the touch side, and on the right side it's the desktop side. So let's put them on the scale. Let's see what's going to happen. So this is mobile touch side. And HTTP requests, we have about 78% of the HTTP requests are coming from the CBC domain. The rest are third parties. So that's okay. When we look at the bytes, and also here we're like 83% coming, the bytes that we're sending to the user are actually coming from CBC.ca. The rest, again, is third parties. That means we have around 250 kilobytes, and we have about 36 HTTP requests. Now let's look at the desktop. Desktop looks a bit different. So that's our desktop side. So literally half of the HTTP requests coming to the client, to the user, are only coming from CBC.ca. The rest actually from third-party scripts from other integration systems that we work with. And when we look at the bytes, you can take the 28 and the 36. 28 is thumbnails.cbc.ca, so you can combine those two things. So about 50% of the bytes that we're sending to the users are from CBC. The rest, again, from other third parties. Fully loaded, we're about 1.5 megabytes. We have 164 HTTP requests. So that was our quick assessment. Is that too heavy? Is it unhealthy? Compared to what? How do we know? What is our baseline? So we were looking for baseline, and again, Steve Souders and the HTTP archive come to the rescue here. And I don't know if not everybody might not know about HTTP archive, but HTTP archive basically is a repository of web performance information, and you can track and monitor trends of all the top Alexa websites. So it gives you a good baseline. That's what we did. So this is how our touch site compares to the HTTP archive mobile. So I think we're pretty good there. We're below average for page size and the HTTP requests. That's not too bad. So I took that from this month, June 2013. When we look at the content breakdown for our desktop site, it looks a bit different. So here we're comparing it to the HTTP archive, the desktop version, and we're above average for page speed and HTTP requests. So that's not too great. So what are our options? How can we successfully measure our weight, our performance? And there are these two ways of doing that, and there will be, I think, also even tomorrow and also today a bunch of those talks specifically about synthetic testing or real user monitoring. So I'm not going to go into too much detail, but I'm going to give you a quick overview. So synthetic testing, you run the test. You measure an experience of an exact one selected configuration. So you say, I'm going to test today the mobile side or the desktop side on IE with a DSL connection. So you get a good baseline performance level that you can establish. You can use the private or the public web page test instance. You can use page speed. You can also use Phantom.js to write your own scripts to query the resources of a page and get the load time, or commercial products, whatever they're out there. So real user monitoring, the user runs the test. And it really measures the experience of the actual user. So you get the peace of mind that that's really, you know what the user actually experiences. So you get to know your user better. And you get concrete information about users' latency, bandwidth, the page load time, and tools that you can use, for example, Boomerang, JS, Google Analytics, and again, some commercial products. So let's look at synthetic testing. How did we do that? So I was dreaming about creating this great dashboard, and then I can show it to my coworkers, and we can figure out how we can do performance better. But then I looked back at HTTP archive, and I thought, well, this is open source, and it looks really good, and it kind of is what I want. So I took that and said, let's set that up. So what I did is set up the HTTP archive. It's fairly simple. You have to have MySQL, you have to have PHP, then you get a web page test key from pad or you have your private instance, you check out the latest source code. You can also get the DB schema, and then even the dump if you want the actual real production data. And then you can start running your batches. Maybe you can set up a cron job to do that. So that's what we did. So we started collecting. So we took about 44 CBC URLs that we have. Again, we can add more stuff. We can also remove stuff. But some of them were the CBC News page, the CBC Sports page, our video player, or any regular store page. And then you can crawl and compute this thing daily. You can monitor and measure trends. And the interesting thing also, you can compare your selected URLs to the actual HTTP production site, so httparchive.org, to get a comparison how you're doing with your URLs and your sites. And then a very nice thing as well, you have that database set up so you can actually run queries against the database to find bottlenecks. And it comes with a bunch of graphs, HTTP archive, but you can also, extend it and provide your own graphs. So here are a few examples how you can query the database. So this is a simple SQL statement. What we're doing here is we are finding the percentage of the selected URLs that use the Google-hosted jQuery version. And that would be something maybe you want to change, or you could get a list of URLs then and say, we have a jQuery version on our server, we're running it through CDN, so there's no need to have two different versions, because people probably also browse through different CBC sites, so then requesting jQuery, the jQuery version again, doesn't need to happen. Another thing is Facebook plugins. So with this query, I could figure out that 48% of our selected URLs are using Facebook plugins directly instead of Giga. That's actually what we should be using. We should be using Giga to use social sharing. So again, also here you could get a list and then go through those URLs and change it and make it better or optimize it more. So that's querying the database, but you can also visualize it. So this is what comes out of the box. You see the URLs that you analyze, you have the load time and the start rendering time that you can see, and again compare to the actual production one. Or what I did here is I created a custom pie, so a regular pie chart that tells me what of our pages, our URLs use ComScore, because it should be included in all of our pages. So we have to do some work that we have to do there. All right, so now that was synthetic testing. So let's do real user monitoring. And I'm very happy even that, Philip, it's there. So I'm using Philip's tool, Boomerang.js, and that helps us to measure the page load time and the bandwidth and more things that you want of the actual real user. So what are we doing? We're looking at 3 specific parameters that we're getting from Boomerang. It's the TDON, the LAT, and the BW, so the perceived load time of the page, HTTP latency in milliseconds, and the bandwidth in bytes. And because everybody wants to come up with cool names, so I thought I have to come up with a cool name, so I used the Boomerang and the Rum. I came up with Captain Rum. So what Captain Rum is what we did is we basically took the script and we included it in a touch news landing page, which then sends the beacon with all the parameters that we need. We also included, we're also collecting the user agent as well. Then we can define the sampling rate. So what it is, I think in the morning I turned it on for a few hours, and you can set it up the way you want. You can also get a cron job to do that. So then after that, you have to parse through the Apache log files for that beacon GIF to extract the parameters and then import them into the database. And what I found was there was a lot of noisy data. So it took me a while first to normalize that, but I figured it out. So let's look at the results, Captain Rum results. Latency. So we're seeing for the touch news landing page, we're seeing pretty much half of the people accessing the site experience a latency of 200 to 300 milliseconds. When we look at the page load time, again for the same page, CBC Touch News landing page, again here also pretty much half, like 50% of the people are experiencing a 2 to 3 seconds page load time to our news landing page for the touch site. When it comes to bandwidth, our bandwidth distribution, again, I got that all from Boomerang. Most, so 41% are accessing our page with half a megabyte to 1.6 megabytes per second. That's kind of, I think, an average, when I look at it, Canada, kind of like a 3G connection average. And then I read a blog post from Steve where he said, well, when you do RUM data, your real user are actually going to experience a page load time twice as long as their corresponding synthetic measurements. So obviously I wanted to see if that is true or what we're doing. So what I did is I compared those two. I wanted to do a comparison, so I compared this. So the setup was for synthetic testing, CBC News touch landing page. What I used for tools, I used a public web page test. I didn't use Mobi test because I felt that I could only select DSL and Wi-Fi, and I wanted to get a proper simulation. Then I also did a second one, which is using Phantom.js to write my own script to start and stop the page load time. And I used Slowy to shape my connection to not have a high-speed connection to properly test that. My data points were for both scenarios 100, so I took 100 data points. And then, my network profile. We had a 3G simulation for web page test because I really wanted to compare apples with apples. And as I mentioned, the Slowy app with the 3G simulation. And then my measurements were the median and the 95th percentile for both. So real user monitoring, same page. I tested the same page, of course. I used my Captain RUM, which means I had Boomerang.js and then put it into the database. After I denoised the data, I had about 4,800 data points that I could work with. And of course, the network profile, it's real user, so I didn't set up a network profile. And as I mentioned, the measurements were the same. All right, so those were the results. So for RUM, we see that the T-done, like the load time, was faster than the synthetic load time for the median. The two synthetic rounds that I did were pretty much the same in terms of page load time. And the 95th percentile was actually above 10 seconds. So my observations from here, with synthetic testing, you have, again, lots of variances possible. What simulation, what network simulation you want to do. Also to simulate properly mobile, like to have all those components like latency. And for RUM, I noticed because my RUM data was faster, it's probably because the user benefited from the cache. And another thing, what I found out, and again, I don't think you would figure that out with synthetic testing, is we have an Android wrapper app, and the Android wrapper app is pointing to the touch site. And when I saw looking through the data was that the Android wrapper app seemed to have always been faster than the regular Android browser if somebody was actually just browsing it on the native default browser. So that was something that I wouldn't have thought comes out of RUM.
All right. So, temptations. I love sweets. I like cookies even more. And of course, we all know that cookies is a method to send state information from your browser back to the origin or back to a server. So one of the things I decided to do was take a look at how many cookies we were setting at CBC.ca. I flushed my cache, cleared my browser, did all that good stuff, and decided to load the front page. And I was shocked to find that we were setting 15 different cookies. After browsing around the site a bit, that number jumped up to 22. That's a lot of cookies. But one thing I want to point out is that it's not necessarily the number of cookies that you're setting, but it's the combined size of those cookies. And this is the cookie header that my browser is sending. And it works out to be just shy of 200 bytes. Now, 200 bytes doesn't seem a lot, but as Barbara pointed out earlier, when you're doing over 100 HTTP requests, that's a lot of data that's coming back to the origin that may not necessarily need to. You won't notice it so much on your desktop, but on a mobile client, that's just additional information that you probably don't want to send. So, how can you still enjoy cookies on a diet? Well, there are a few tips that you can use. The first one is using the path option. The path option in a cookie sort of limits the scope of when that cookie is going to be sent. So if, for example, this cookie is only needed for the news section of the page, then make sure you set the path option to just be /news. And then when a user browses the rest of your site, that cookie will not be sent. You can also store your static assets at a different domain. Static assets such as images, JavaScript, CSS can't even handle or parse a cookie in the first place, so there's no point for you to send that information for those particular objects. So one way of doing that is putting those assets in a different domain and setting your cookies such that you're not using like a wildcard. So, for example, www.cbc.ca, because these assets are at a different subdomain, then the cookie won't be sent for fetching those objects. Don't use cookies for fun. I know a lot of CMSs and frameworks may have cookies set on by default for tracking purposes. In some cases, if you're using a CDN, the cookie won't even ever make it back to the origin anyways, and the tracking will be useless. So you might as well just take a look at it and make sure that if you don't need them, then don't use them, and double check that those settings are turned off. That's it. All right, yep. Sweet.
All right, other temptations. Okay, I have to go back to the mic. Third-party monsters, that's how I call them. What are monsters? What kind of monsters I'm talking about? It's ads, it's tracking, it's social buttons, all those good things. Well, they're unpredictable. They're scary, I find. They're disruptive and sneaky. And they could totally slow down your site. They could also bring down your site. I remember the Business Insider spoof single point of failure when Twitter was down, and I think there's even a video on YouTube where you can see that the Business Insider website did not load at all because Twitter was down, and they included Twitter obviously on their page. And obviously, they could do things you don't want them to do. You don't know what that JavaScript does. So watch for that. And it will add weight and complexity to your page. So what would a life without ads feel like if we didn't have to put ads on our pages? I know that Ymail, they turned off ads for 3 days, and the page load time dropped by 73%. That's a lot. So, of course, I was curious, and I wanted to know what would happen if we were to turn off ads. So, and we did that for the CBC Touch mobile site, at least. And we use normally server-side, the server-side solution of Google's ads code. But in this case, there was an incident where we actually saw client-side ads code being used. And with that, or without using that, we reduced our page load time by 40%. Using server-side ads code versus client-side ads code saved us about 20% of page load time. All right. How can we get in shape?
All right, get in shape. Awesome. So there's some other things that you can do on the back-end side, on the server side, that would help you with increasing your performance. So this isn't necessarily front-end optimization. Back-end optimization. But the obvious one would be gzip compression or last mile acceleration. Because the majority of the assets that you download are text-based, again, JavaScript, CSS, and HTML, you can further decrease the size of those assets by gzip compressing it before you send it to the browser. And all modern-day web servers support this. And even if it doesn't, you could take advantage of a CDN. CDNs like Akamai will automatically handle this gzip compression for you as well. One of the challenges that we have at CBC is some of our eyeballs are in really rural areas, especially up north in northern Canada, and their net connections aren't as fast as what we're used to. So one of the advantages of using a CDN for us is getting that content closer to them. Yellowknife, Whitehorse, their servers are, Akamai has servers in those locations, and that helps us a lot with getting that content to those users quicker. As I mentioned earlier, just use cookies where necessary, and take advantages of caches, browser caches, CDNs, ISP caches. Don't cache bust, and use them to their fullest potential.
Right. dedicated mobile sites. Yeah, so we are using dedicated mobile sites. So we have 3 different sites at the CBC. So we use server-side optimization and device detection to do that. So we decide on the server what we want to serve to the user. So we have the text, the rich, and the touch side for different optimized experiences. And we also serve 3 different images sizes for those 3 different websites to optimize there as well. And then we use edge side include technology for device detection and some conditional loading if needed. And I also want to bring up the point of responsive web design. There are people who are for it, people are against it, and I'm not giving any opinion here, but what I know is that responsive web design, as Guy's research or report says, it got better from last year, but still 72% of the sites using responsive design don't optimize for mobile, so you're still serving the heavy page load or page size to the user. So that is obviously not optimal. There are options that you can use. One is called RES, which stands for Responsive Web Design with Server-Side Components. So it's a combination of both. You do the heavy resource lifting on the server and the rest through media queries or whatever on the client side. We'll have an office hour right after this talk, and if you want to know more how we use that, I can give you some examples. But I wanted to keep that in 40 minutes today, so you can ask us later. So, yeah, let's talk about exercises that work for CBC.
All right, so the power of the if-modified since header. One of the things with news is that people want it as fast as possible. And because of that, we can't really set a cache time on a particular news article. We can't say, 5 minutes, 10 minutes, because the news writers will complain and say, hey, I hit post in my CMS system, how come it's not appearing on the site right away? We need to beat out CNN and Twitter and all the other competition that's out there. So our caching strategy at CBC was leveraging the if-modified since header as much as possible. And this allows us to keep objects in caches, and when they're updated, the cache updates them instantaneously. So our TTLs are set really low, 30 seconds, in some cases 15, and that's just to sort of protect us from the brunt of all these IMS requests coming back to us. But as soon as that object changes, the cache knows about it right away and updates the object in its store. So I'll give you an example of this. We have a photo gallery API, as we call it, and allows users or developers at CBC to include photo galleries in whatever portion of the site they want. The backend is written in PHP, and naturally it didn't support the IMS request. So on average, the number of data that was being returned for a call to this API was around 28K. And because these photo galleries the same photo gallery would be included in different portions of the site, every time the user would go to the other portion, he would have to download the entire XML data that described this photo gallery again. And this is because the backend didn't support the if-modified since request or IMS header. What normally happens is the browser, if it already has that object in its local cache, will say, hey, has this changed since I last got it? If, in this particular situation, the API didn't know how to handle that request and said, I don't know what you're talking about, here it is anyways, here's your 28K, and that really suffered for performance-wise. So what we did was we said, hey, let's handle this request, and we implemented it a couple weeks later, and you can see now that the average payload size of all of these requests combined was 12 kilobytes. So at the top is an example of a request. This one happened to be 21K, and then the user went through a different part of the site, had to reload the same photo gallery, but in this case, only 250 bytes were returned instead, because the backend said, hey, the copy you have in cache is the same one, it's still fresh, I'm not going to send you the XML again. Another thing that we discovered was our 404 page. And one of the interesting things was that even though you're fetching an asset, like say a JPEG, and you have a custom 404 page, that entire HTML that describes that 404 page is sent along with the 404 header, with the error message. And now this kind of sucks in the sense that if you have broken images on your site, the image won't load, but your browser is still downloading all 5K in our case of the 404 page. And this is what it looks like. It has ad code, it has a full navigation, and it has messaging. And this page would never be seen by a user, especially during if it's being sent for a broken image. So what we decided to do was reduce the size of the 404 page just for these assets, just for JPEGs, CSSs, JavaScript, anything that the user wouldn't necessarily browse to. And we made it a lot lighter. We used the data URI scheme for our logo, and we just have a simple object not found copy. So before, our 404 page was 5.2K, and after, we were only down to 1K, about 80% savings. And for us, that helped us a lot, especially with bandwidth, because with a site this large, we get about 120 to 130 404s per second. And over the course of a month, that equates to quite a bit of bandwidth. So being able to reduce our bandwidth, at least on the 404 side, on the 404 error page, by 80% was significant. You?
Cool. All right. Another thing that we did is, from a front-end perspective, is the global shell. So the global shell is all mobile sites at the CBC use that global shell, so it's shared by all. That's the visual presentation. So you have the header and the footer with some search. And then the non-visual representations, you have a bunch of SSI variables, and then the global scripts, third-party scripts, style sheets. So they're all, either at the bottom or at the top. And I want to point out is that improvement is really easier than you think sometimes, especially in this case. So I saw the global shell and I thought, let's just improve this. And how can we do that? I followed the regular things that the best practice that you find on Google or Yahoo's page, how to make websites faster. So again, this wasn't rocket science that I did. So what I did is I refactored the code. I removed old and unused legacy code. I moved the scripts to the bottom of the page. I minified, concatenated everything so that I reduced the HTTP requests. So I got faster load times. And while I was doing that, I thought, of course, I'm not going to do this every day, so I want to optimize it and automate it. And I think that's a very nice and easy thing, or not an easy thing to do, but a very good thing to do is that you include performance optimization into your deployment process and release process. So we use Maven to build our stuff, our software to our environments. And I found a lot of great automated built-in tools, most of them free. I used Clojure Compiler. I used the Minify Maven plugin, an HTML compressor that compressed my HTML for me. I used Confess to actually, while I was deploying things, I could still quickly use Confess to see the page load time or get some numbers right on the build. And I used CSS embedded the Java file or Compass for data URI. So also that was all automated, so I didn't have to do any of this manually. If you can or you don't want to use Maven, you should for sure be using task runners or scaffolding, especially Grunt or Yeoman. We're looking into Grunt right now, and I think that's a very nice thing. And also put it in your CI, or use that in your CI as well. I think Marcel from Twitter, he showed the YSlow integration with Jenkins yesterday, which is cool. Another thing is the spoof check from the guys at eBay, and I think what they do is as soon as they detect some sort of a spoof that could happen, your build process fails. So you're actually not being able to deploy anything. So you can automate that as well, which is pretty neat. Going back to the global shell, what were the results? So we, looking at the before and after just the JavaScript files, we had 9 requests before, and after we dropped it to 4 requests. Overall, those were the results. So we're all improvements. We didn't make it worse. We just got better. So 25% improvement for HTTP requests. Page weight, we got about 3% out of there. But I think it's important to look at the 30% to visually complete, because this is, and the same as the start to render, because this is really the time that the user benefits from it. And 30 and 26% I feel were a good improvement. So yes, we slimmed down, so that's great, and we're happy about that. But the danger with all diets, whoever has been before on a diet, is the yo-yo effect, because you slim down, but then you forget, and then you gain your weight back. So you have to be careful about that. So if you don't monitor your weight, you can also make it worse. And that's almost what happened to us. So the monsters came back again. So let me show you that. So this is a keynote report, where I took the numbers from the keynote report. And you see here, that was when we did the improvement to the global shell. You see the page the page load time went down. That's great. This spike, forget about it, that was an ISP issue, so we're not counting that. But then something happened. We got a spike. And I think, we started getting reports from Keynote saying, you're going above a certain page load time. So this was when client-side ads code was introduced. So our ads department was playing or using client-side ads code. And we actually went almost up to 10 seconds, which was really bad. And that's when we unplugged and said, okay, let's turn off ads. That's also why we got this comparison that I showed you before. So we turned ads. We turned off ads and said we got to fix that. This is unacceptable. So we did that, and then we still had to make some adjustments. But then we got back to the server side ads and back to the normal what we had before. And this is important. So ads shouldn't take that long. I mean, there are obviously also ways of improving that, asynchronous loading and not blocking. But still, you got to remember, and this is a source that I took from Nielsen, is that if your page loads slow, the chances that people will look at promotional space is very low, basically just 1%. But if you really give them a fast loading page, even if you put 2 or 3 ads on there, probably 20% will actually look at your promotional area. So keep that in mind. All right, to wrap that up, some fitness tips for you. Bring everyone on board. Create a culture of performance. I think we're doing pretty well, and my manager and our managers, they're on board with that, and they want to see this working. So I'm happy about that, and it's fun. Start today, collect measurements. Even if you don't know what to do yet with them, just start collecting. You will use them probably at some point. You can use commercial or free tools. There are lots out there. What I like to visualize data and complexity, especially with this little ads example there, to show that to the departments at CBC and see this is what could happen when you don't include ads properly. So show the before and after as well. Automate your performance optimization. Use Grunt or use Maven and all those tools that are available there. It's really helpful, and it's fun. Watch those third-party monsters, so evaluate the impact, check if they have a server-side solution whenever you have to include a third-party script, or see how you can optimize the client-side solution, so watch out for those. Serve only what the client needs, so we use device detection and server-side, maybe use some res if you want to do that. Do both, so use RUM and synthetic testing, because you want to get to know the user's performance and also your features, how they work actually in the real world. Monitor your fitness level, set up reports. We have Keynote reports that, again, if something goes wrong, if it goes above 8-9 seconds, we get informed and we know what's going on, or we can investigate. Also share your ideas and knowledge. Stand here and share that, or we also created a web performance working group where we talk about those topics, where we push for certain things, and also to bring people on board. Set a performance budget. Say, you know what, this is it shouldn't load slower than such and such number. If you're not sure how a mock or a prototype or a design that you get from designers work, just do a quick test, do a quick performance test to see what the impact is. And last but not least, I think there's always room for improvement. So keep the momentum, just don't stop, because again, you can always improve. All right, that's it.
Thanks a lot, guys.
Thank you.